Here we have a question. If u plus v square equal to x, v plus w square equal to y, w plus u square equal to z, then find Jacobian of u v w with respect to x, y, z. We have given that x equal to u plus v square, y is equal to v plus w square, and z is equal to w plus u square. Then we have to find Jacobian of u v w with respect to x, y, z. Since the given functions are explicit functions, so we use the formula jj dash is equal to 1. That is Jacobian of xy with xyz with respect to uvw multiplied by Jacobian of uvw with respect to xy, which is equal to 1. Now in this example, just look here. X is the function of uvw, y is function of uvw, z is function of uvw. So we are able to find out the Jacobian of x, y, z with respect to uvw, and then if we apply the formula jz is equal to 1, then we can easily find out what is the Jacobian of uvw with respect to x, y, z. Now consider z is equal to Jacobian of x, y, z with respect to uvw, which can be given as determinant of del x del u plus del x del u, del x del v, del x del w, del y del u, del y del v, del y del w, del z del u, del z del v, del z del w. Now let us try to calculate what is del x del u. Del x del u is nothing but del x del u, it is 1. Del x del v is 2v. Del x del w is 0 because this is free from w. Similarly, del y del u is 0. Del y del v is 1. Del y del w is 2w. Right. And then del z del u is 2u. Del z del v is 0. And del z del w is 1. So let us substitute all these values. Then we have a determinant 1, 1, 2v, 0 in the first row. This is the first row. Then 0, 1, 2v, 2w, second row, and 2u, 0, 1 is the third row. Let us try to simplify the Jacobian determinant. 1 into, how to solve this? 1 into, let us leave this row and this column. So 1 minus 0, the first part. Then if we come to the second part, minus 2v, minus 2v. So leave this column and this row. 0 minus 2u into 2w, which is equal to 4uw, second part, and the third one is already 0. So 0, again let us leave this row and this column, 0 minus 2u. So if we simplify, this is 1, this is 1, and this is minus and minus will become plus. 2v into 4uw is 8uvw. So this is the Jacobian of xyz with respect to uvw. So Jacobian of xyz with respect to uvw is 1 plus 8uvw. Therefore, z is equal to Jacobian of uvw with respect to xyz is nothing but 1 upon j, which is equal to 1 upon 1 plus 8uvw. Hence, Jacobian of uvw with respect to xyz is 1 upon 1 plus 8uvw. This is the desired result. Thank you.